Hello and welcome to this 15th lecture of our course on blockchain and its applications. Also, this is the third lecture on the topic of blockchain elements that we started last lecture, and where we discussed the basic structure of a Bitcoin block. We talked about the header of the block, how we can generate these types of blocks by solving a cryptographic puzzle. And then we talked about how the transactions are organized in the blocks, and we have also introduced the fact that these transactions are carried out, which means that payment of say certain number of bitcoins from one party to another, maybe from Alice to Bob. We took this example that Alice is paying 40 bitcoins and she had initially got some 100 bitcoins to somebody else and now sending these 40 bitcoins to Bob, and we said that this sending of these bitcoins from Alice to Bob would be captured in a block of the Bitcoin blockchain in the form of transactions, and these are to be carried out in a way that Bob would know indeed that Alice is the right person who is sending it. Also, Bob would be able to prove that those 40 bitcoins were sent by Alice to him only, it was not sent to somebody else, and then Bob is trying to respend those ones. So, that was what we have discussed before. And then the concepts that we plan to cover today that include that what are these Bitcoin scripts. We will go through one of the very standard Bitcoin scripts that are used, very commonly used I would say, and then understand how it works in detail. And then also we will look at a couple of other interesting Bitcoin scripts, so that you can get an idea about how these scripts can automate various types of payment options. So, let us take a look at those concepts in this particular lecture, and the keywords for today's lecture are first of all Bitcoin script, as we said, then this script pub key and script sig, which we had introduced in our last lecture, and then we will see how a stack implementation is done, so that the script processing can be done in an automated manner whenever these requirements are coming about Bob trying to spend say the bitcoins he received, say 40 bitcoins from Alice, and how this can actually be done by processing all these scripts using a stack. So, let us look at this example. So, there are these two concepts. First of all, the transaction input, the other is the transaction output. Let us take the example when Alice has got these 100 bitcoins and then Alice is making a payment of 40 bitcoins to Bob. So, in this case, what is the output? So, Alice is outputting those 40 bitcoins to Bob. So, that is what is called the transaction output. And when this output is happening, then this script pub key is used. We will see what it means, what are written here, all these kinds of numbers and so on. And now, what is the transaction input? So, Bob when is now trying to claim those 40 bitcoins which he received from Alice, and now claiming means that he would be actually using it for some other purpose, like say paying 30 bitcoins to Carol. So, that is when this transaction input will be used. So, Alice is sending 40 bitcoins to Bob and Bob will be sending 30 bitcoins to Carol. So, when Alice is outputting these 40 bitcoins to Bob, this script pub key would be used, and when Bob is claiming those 40 bitcoins in order to make a payment to Carol of say 30 bitcoins, that is when this transaction input is considered and when the script sig will actually be used. Okay. Of course, that also means that when Alice was making use of those 40 bitcoins for sending to Bob, how was Alice being able to do it? Because she had those 100 bitcoins. Okay. So, when she was generating this transaction of transferring 40 bitcoins to Bob, she also had to use this notion of claiming of those 100 bitcoins in the form of the transaction input. So, we have to keep in mind that whatever we are saying that Bob is doing, the same was done by Alice, and again if Carol wants to spend those 30 bitcoins, then Carol also will have to do the same thing by using what are called these transaction inputs. That is the basic concept that one has to understand. Second thing is that, as we had introduced in the last lecture, that Bob possibly provided some service to Alice or sent some goods to Alice, and then Alice is now making the payment using those 40 bitcoins. So, as we said, Bob has to tell Alice that you please pay 40 bitcoins to this public key, but it is not actually the public key that is shared with Alice. Instead, a hash of that public key is shared with Alice. Why is it done so? Because otherwise, through those public keys, people might be able to track Bob. In case one can relate a public key to Bob, somewhere it is made known, because public keys get known to anybody. So, people would know that Alice is making payment of 40 bitcoins to Bob, and Bob might be getting lot of such bitcoins from other places. In order to ensure anonymity, that association of the payee to Bob as a person when Alice is making the payment, that is avoided. So, since a public key can be linked to an individual like Bob, the payment is actually made by Alice to the hash of the public key, and that is what we said is that pay to public key hash. So, that is the first concept. So, now we see that this script pub key. So, Alice is sending those 40 bitcoins to Bob. So, what Alice would be doing is that Alice will be sending this script pub key, and we have something written here. We will explain as we show how this is actually processed. So, now we have this first script, which is this script pub key, which will be used by Alice to while sending those 40 bitcoins to Bob. And then when Alice has sent, and then Bob has got those, Bob is claiming, Bob will be using those script sig. So, you can see for more of the detailed steps, if you go to this particular site where it talks about details of how the transactions are actually carried out. So, in this particular site, which was linked from our lecture, if you go, you will get more details about what transactions mean, and then how the actual encryption is done. As we said that script pub key is used. So, what is used for generating that script pub key, all these details you can get from this particular site, and of course, there are other materials, but this is the one which explains these concepts in very simple terms, and you can very easily follow and get to more details. You can follow the additional links, and to whatever level of detail you are interested in, you can go through this particular site and its further hyperlinks that are provided here. So, this is really a good resource for you to understand the concepts in more detail beyond what is there in our lecture and also in the textbooks. Now, we see that how these Bitcoin scripts work, and we said that this is a forth-like language, it is not Turing complete and is stack based and so on. So, what it means to process these scripts? Let us take this example. So, we have this script pub key, as we said that Alice will be using script pub key to send those 40 bitcoins to Bob. So, this script pub key part is from here to here. So, this is our script pub key, and which has got some of these keywords like op dope. So, op dope, op hash 160. So, these are the keywords in this scripting language, and then also there are certain constants like this what we denote here in angular brackets like pub key hash, and then we have this sig and then pub key and so on. So, we will see that how these keywords they are used to process whatever are now you can treat those as the parameters for actually applying those types of operations. So, op dope, op hash 160 you can consider these as operations that are to be performed, and some of them take some inputs as parameters, and some of them just keep they have their inbuilt interpretation as to what they are supposed to do. So, what we have? We have the script pub key and script sig, and now consider the situation that Alice has sent those 40 bitcoins to Bob, and now Bob is trying to claim those 40 bitcoins, and this claiming, as I said, would be when Bob would like to spend those 40 bitcoins, maybe by transferring say 30 bitcoins to Carol. So, in that context we are talking about. Now, when Alice has sent those 40 bitcoins to Bob, Alice had sent the script pub key part. So, only this part was sent by Alice to Bob, and then when Bob is trying to claim, Bob will be using this, adding the script sig, and then these two together is now going to be processed by the stack. So, the stack is initially empty and both the scripts are combined, input followed by output. So, if you remember, we said that script pub key is the input part and the script sig is the output part. So, input followed by output, and then we will see that as these are inserted in the stack and the operations are done, which will be, so initially we will be pushing something to the stack and then popping from it. So, we will see how the processing is done. Now, first of all, we will proceed with these steps and then we will come back and take a real example from Bitcoin. So, let us first see how it works, what we mean by pushing to the stack and so on, and what are the different stages by which it can get verified whether indeed those were sent by Alice and it was meant only for Bob and nobody else. So, now what we do is that we consider this situation where the stack is initially empty, and now one by one what we do is that we will process that. So, if you look at this example, so we have this part here, that is from sig pub key op dope all the way up to op check sig, which is a combined this output, not the output, the combination of these two different scripts. So, we are processing them one by one. So, first is that we push sig to the stack, then in the next step we push pub key to the stack, and then if you see here that sig was the first item, then pub key. So, these have been pushed one after the another, and then also we mentioned that whatever we have in angular brackets, these are some constants which have been added, and then we have the first operation of op dup. So, op dup, as I said, is a keyword in the scripting language, and then op dup is going to do what? Op dup will be duplicating the top of the stack. So, let us see that after we have pushed sig and then we have pushed pub key. So, this is the current status of the stack. So, we have the top two items pushed to the stack one after another, and then what we show below is that what part is still left in that combined script. And now, we have the operation of op dup. So, what it does? It is basically this operation would be duplicating the top of the stack. And what was the top of the stack at that time? The top of the stack was the pub key. So, the pub key will be duplicated, and that is what is shown here, that pub key has been duplicated. And then on the left below we also show which part is now left. So, up to op dup we have combined the steps, we have completed the steps, and then the next one is that it is saying that we do a op hash 160. So, what it means that it actually takes the hash of the top of the stack. So, top stack item is hashed, and then this hashing is following a particular algorithm, and then this 160 actually refers to this EMD 160 hashing technique. So, there are different standards one can follow. So, we are just talking about one particular standard, say this hash 160, op hash 160, we will generate the hash of the top stack item. So, if you see here, the top stack item was the pub key, which was the duplicate of the previous top of the stack item. So, this op hash 160 will create the hash of the public key. So, this pub key has been hashed, actually it is rather we should say that it was the previous top of the stack, but indeed that was simply a duplicate of this pub key. So, what we have here is that by this step of OP hash 160, we have been able to get the hash of the public key. And then what we are left with? We are left with now in the stack this pub key hash and the from the script we are still left with the pub key hash OP equal verify and OP check SIG part of it. So, what we do here is that we now take a look at the next step, and then in the next step what is done is that this pub key hash which was there, if you remember here, the next part here was the pub key hash. So, this pub key hash is now pushed to the stack. So, this constant pub key hash has been now pushed to the stack. So, what we have in the stack is that we have the SIG, the pub key, the pub hash which was obtained by taking hash of the pub key which was there at the top of the stack above this pub key that you can see here. And now what we have is that this pub key hash which was there as part of the script, that has been pushed to the stack. And then what is now left in the stack in the script? The script now is still left with this OP equal verify and then OP check SIG. So, this is the current state of the stack, what is there in the stack, the various elements, and then we have these two parts which are still left in our script. Now, interestingly, we have this operation of OP equal verify. Now, what does OP equal verify do? OP equal verify, this performs the operation of checking the equality between the top two stack items. Okay. So, what are the two top stack items? These are pub hash and the pub key hash. So, these will be checked, and if they match, then only it will proceed to the next step. So, what is happening is that here whenever we have these operations which are checking for equality, the underlying processing is such that if only it returns true, then you will process, otherwise it will come out of it, meaning that these two scripts are not matching, and the claim that Bob is trying to make about those 40 bitcoins, that cannot be allowed to proceed. So, here this OP equal verify will check for equality between the pub key hash and the pub hash, and then only if they match, then it will proceed to the next step. Now, you might wonder what is all this going on, so that the checking actually is happening. So, understand that what did Bob do? Bob had pushed the SIG and his pub key. Okay. That pub key was duplicated, and from that the hash was generated, which is this pub hash that you see in this slide. And what was that pub key hash? The pub key hash was the one that was included in the script pub key by Alice. And how did she got it, and what was that pub key hash? That was the hash of the public key of Bob that he had shared with Alice to make the payment to. So, in the script pub key we had the pub key hash, and then what Bob has done? Bob in his SIG script, that script SIG, Bob had his SIG and the pub key. So, what has been done so far is that pub key was duplicated, that means the one that Bob had provided was duplicated, and then the hash was generated, which is the pub hash that you see here, and then the pub key hash, that is the address to which Alice had made the payment. These two are now checked for equality, and that is what is being done in this slide in this OP equal verify operation. And then if it matches, would mean what? What does it guarantee? It guarantees that whatever is the public key of Bob, a hash of that is the one to which Alice had made the payment. Otherwise, what can happen is that Alice could have made the payment to somebody else's public key hash, and now Bob is trying to claim that. So, that part can be verified that the pub key hash to which Alice had made the payment is indeed the hash of the public key that Bob is now providing. If they do not match, that means there is something wrong. Alice had possibly made it to somebody else, and now Bob is trying to claim it, or Bob does not know the public key, and it is not able to proceed with it. So, Bob should not be able to claim those 40 bitcoins. But if the two match by this OP equal verify, we can proceed to the next step. And what is that? That is OP check sig, and at that time what we have, if you see that these OP equal verify would verify them and they will be popped from the stack. So, the stack was now left with only this pub key and sig. So, that is the status of pub key and sig here. And now, the final step, which is the most important step, that is that it will check for the signature. That means that how after all this it can be guaranteed that Bob is indeed the holder of the private key for which the corresponding public key, which is the one that so far we have discussed. So, it is possible that it was not Alice and somebody impersonating, it was not Bob and somebody impersonating as Bob is now trying to make the or claim the payment that 40 bitcoins that Alice had transferred to Bob. So, again let me repeat for your understanding that first part was to ensure till the last slide was that the payment was made by Alice to the public key hash, and Bob has confirmed that it is the hash of his public key. So, so far it is guaranteed that whatever was the content of that payment script, that was meant for Bob for sure, because Bob's public key's hash matches with the public key hash that was included in the payment part. But now, Bob is trying to claim those 40 bitcoins by now spending a part of it, say 30 bitcoins for Carol. So, now Bob has to also ensure that this public key is indeed his. How that can be done? So, if Bob is really Bob and not somebody else claiming as Bob, then Bob must be knowing the private key of Bob, and if Bob knows the private key of Bob, Bob has to encrypt something with his private key, and that it should be possible to decrypt with the public key that we are talking about. So, that should be clear. Now, what is that something that Bob has encrypted with his private key, which can only be decrypted with his public key, and then we can be sure that it was meant for Bob and Bob only. So, all those details, as I said, you can see from this site. Okay. So, you will get all the details about what exactly is encrypted by the private key of Bob. And then once it is done, this OP check sig, so the signature is checked based on the two top items of the stack, and if these two match, that means it returns true, then what is guaranteed is that all the steps that Alice made payment to Bob's public key hash, and then Bob could confirm that that hash matches with the hash of his public key, and then that public key can be used to decrypt something which has been encrypted with Bob's private key. All these together prove that indeed Alice wanted to make the payment, and Bob is now the right person who is claiming that say in our example of 40 bitcoins by spending a part of it on somebody else. So, all these steps together ensure that the payment is being made in a secure fashion. So, as you can see that we are making use of the hash, the cryptographic hash that we talked about in the basic cryptographic primitives discussions, and also the digital signatures, how they are being used, and then this is how it becomes secure to carry out the transactions in Bitcoin. Now, having said that, let me go back a little and then show you that there are some real examples from Bitcoin, which is what I wanted to show to you, and I will go to one particular such example where we have a particular transaction. So, this is a transaction that we show here. If you see at the top, this is a transaction hash, and this transaction is part of this block number 704000. So, you too can take a look at the same block by going to btcd.com, and then you can figure out that it has got this particular transaction. So, this is one of the several transactions which are there in this particular block. So, for this transaction we also have this hash. Mind it, that hash is the one that would go into the Merkle tree for your understanding. And now, if you go down here, if you see that it is talking about this input scripts, and if you look at this here, it has got this P2PKH, that is pay to public key hash that we talked about, and then output scripts, it is having this P2PKH, and you see that whatever we have talked about so far, that type of example is given here. So, there are two output scripts, that whatever was there as the input, it is making two payments to two different parties, and then what we see here is that the first one has OP dup OP hash 160 like we talked about, and then I have this detailed public key here, and then OP equal verify OP check sig. So, all these are actually exactly similar to what we discussed before. So, there are two such output scripts. So, this transaction is taking one as input script and making two output scripts, and you have further details here. So, if you go back to this particular block, of course, you will see that it had got 1, 2, 6, 9 number of transactions, and there are so many transactions listed here. I took up one of them, and then based on that we have got these types of scripts. And as mentioned, this is not the only type of script that is possible. There are several other types of scripts that are also possible, and you can see the different possibilities by going through the material, and you can also explore the other blocks as is there in this particular site, which we have seen before. So, next what we will talk about is that we will talk about the overall set of instructions. So, of course, not all the instructions are being discussed here. We have seen some of these, the opcodes. So, they include arithmetic operations, and then if then conditions and logical operators, data handling like OP dup, that it duplicates the data, and then cryptographic operations like hash functions, signature verification. We have talked about this generating hash. If you remember, we created the hash and so on. So, all these are part of this particular scripting language, and then one can also have multi-signature verification. So, it is not that only one signature will be verified, that of Alice. It could be that Alice and Bob together will have to confirm that the payment can be made, and you can have multiple such different signatures that can be verified. There are also several other more interesting scripts. We have talked about one very standard simple script, and there are cases like this. Say for example, if the script pub key simply does a OP return, that means that the first step that will be there. So, this will be pushed at the top of the stack. So, first the script sig part will be put, and then script pub key will be pushed to the will be part of the script. So, the combined script will be OP return followed by script sig, and then what happens is OP return when it is pushed. So, then that would return that it is not going to do any further processing, and it will simply return. Anyone can spend means that there is no particular pub key that is involved in the script pub key. So, nothing is mentioned. So, the script sig will be OP true, means that if that is there in the stack. So, first thing that will be popped is OP true, means no matter whatever is the content, the first such operation is OP true, means irrespective of any other consideration, it will be returning true. So, anyone will be able to claim that money. And then one can have a little bit more interesting scripts, like where the funds can be frozen until a time in future. So, what happens is that an expiry time will be put. So, Alice can say that you can get the fund only on say 15th of November 2021. So, what happens is that when all these scripts are processed, this particular combination of script pub key and script sig, then what at the time of popping these values. So, it will get the expiry time, and which will be that time of November in 2021, and then what it will do is that it will match by this OP check lock time verify. So, what it will do is that it will check that the current system time is it after the expiry time that is given. So, if it is before that, that means it will return false. So, the further such operations will not be processed at all. So, it will check the current system time with the expiry time, that means the time till which these funds are frozen, and if the system time is not after that, then it will return false and no further processing would be done, and then in that case if it was from Alice to Bob, Bob will not be able to claim those. In fact, you can see that and of course, that if it is after that, then you see the normal processing will be done, and then it will be checking that the remaining part about the correctness of the public key and the signature and so on, and then Bob would be able to claim. Otherwise, it will drop the remaining such parts of the script, the remaining operations that are there. And you can take a look at this site as well, where you will get lot of interesting scripts, and some of the scripts are the ones that we have shown here in the lecture so far, and there are several other very interesting scripts, and it has got a exhaustive list of all these different types of operations that you can do, and stack based processing and so on. So, you can take a look at these, and there are many such interesting scripts that are also listed here, and a few of them we have only discussed in this lecture, and you see that the standard ones are mentioned here, like freezing funds until a time, that the one I explained, and you can see how it is processed, more details are there. So, this is a very interesting site which I would always recommend you to visit and understand. So, with that we come to the end of our today's lecture. In conclusion, we would like to summarize what we have discussed. We have discussed in detail how the scripts are used for generating input and output of Bitcoin transactions, and very importantly, now we have understood the applications of public key cryptography and digital signature for cryptographically protecting the transactions. Okay. And then the transactions, of course, will go into the blocks, and the based on the Merkle root, the block header will be generated, and then from one block there will be another block, the two will be connected, because the second block will have the previous hash, that means it will have the hash of the previous block, and the third block will have the hash of the second block, and so on and so forth. So, all these will be chained together. So, from the transactions we will have these blocks created and the blocks connected in a chain, and the transactions which are transferring of these bitcoins in the Bitcoin blockchain network, how they can be done by means of these different types of scripts, and how we can build in many different interesting such constraints on the ability for the recipient to spend the bitcoins. So, all these we have discussed, and we have pointed to more such resources on the internet which you can make use of. And once again we have the same set of references that we talked about, and as I mentioned that in addition to these two, there are many such very interesting, very useful internet resources, and you are all encouraged to take a look at those. And there are of course many several such very interesting other textbook also, and you can try to get access to those maybe in your libraries and so on, and that will enrich whatever you are learning through these online lectures. So, I would expect that you will have a good understanding of these concepts. So, in our next lecture we will see that having understood the content of the blocks, we will see how these blocks are actually tied together in a chain. We know how to do it, but then how the different nodes in the network get those blocks, how it propagates, how actually the miners generate the blocks. We will take a look at those different topics in our next class. So, that brings us to the end of the lecture today. Thank you very much for your attention.